of 10 to the 1 ppm. It is a large amount, and because it's highly active, it can be done only in a lab which is familiar, they have blow boxes and so on. And the idea is as follows. I think it would be a very interesting experiment to try and answer the question, during electrolytic loading or any other loading, does the hydrogen get loaded uniformly, or does it go and sit in special pockets? Everybody has been suspicious that there are special regions, so if only we can use the tritium labeled hydrogen and do an autoradiograph, we'll be able to find out whether there are such hotspots. So far we haven't got any indication to that, but the experiments are going on. The other experiment which we are carrying out, this is being done with the fuel reprocessing division, which is a plutonium reprocessing plant, and they have all the facilities for handling highly radioactive solutions. The other experiment is done jointly with the analytical chemistry division and the radiation systems division, and this is tritium generation in commercial nickel cadmium batteries. We, if you recall, reported at the Nagoya meeting 1992. We are probably the first group to report the production of tritium in ordinary light water cells, which was subsequently confirmed by Dr. Notoya and others from Hokkaido, and since then many other groups in light hydrogen loaded systems. And as a continuation, we asked the question, is it possible that tritium is being produced in ordinary commercial nickel cadmium cells? So I have something to report on that, I'll come back to that. Effect of magnetic field on resistivity of hydrogen loaded nickel wire. This is a continuation again of the work reported. Our attempts to try and reproduce a Piantelli experiment. But there is one interesting observation on the resistivity which Dr. Starr just now mentioned. I think you will be interested in looking at this, and I would appreciate his comments. I'll come back to this also. Transportation of elements during germination of seeds being done with the biotechnology division and the analytical division. This is the good old biological transportation experiment, or the so-called Cabran effect. Is there a change in elemental composition? I think it's of very fundamental importance to science to be able to answer the question. I know that it's like cold fusion itself is also a controversial topic, but some work is going on. Of course, we don't have results as yet, but I'll tell you about it. Last category is the third category, work being done in other groups of BAR, mostly the chemistry related groups on electrolytic loading with palladium D2O systems, and one initial attempt with the strontium cerium oxide proton conductor, but none of them have any positive results, except in the case of one, which if I have time I will mention. So this is an overview of the more or less 12 experiments underway, but since there have been no major results, we did not present any papers, formal papers in this conference. Now, with the permission, Chairman, I'll go through some details. You can cut me off whenever you want to call it off. Let me go to paper number I.3. I'll just flash for you this palladium autoradiograph which we have been talking about. And these are the original negatives. These are wires of palladium loaded simple gas loading technique. And after loading it, it's kept in contact with the X-ray film. And the question is, the interesting point is 100% reproducible. Anybody who repeats it gets the autoradiograph. But the unfortunate point is these autoradiographs seem to occur only in the presence of hydrogen or air, which seems to suggest immediately, aha, it's a chemical effect. It's a hydrogen-oxygen combination which is somehow causing a chemical reaction in the film. This was the first allegation right from day one. But what I would like to point out is the filter experiment. Any number of, we must have done about 300 or 400 such autographs over the past so many years. For example, here in the same film on the other side of this, we have a single white paper. Of course, paper is porous, so one could argue that hydrogen from the wire goes through the porous paper into the film. But then here are some with thick mylar, and still you get an image. And here is a stack of 10 black papers, which is still giving. This is the contact. I will flash a few more. It seems to suggest that there is something more interesting going on. It's not a simple explanation. Here again are palladium hydride, palladium 41. This is the contact on one side directly. This is the various thickness. Now here is a thin mylar, and this is thickness. Thin mylar is still giving a small amount of very faint image. You can see it. Thick mylar has completely stopped it. Whereas a washed X-ray film, the same thickness, is still giving. Now, if this phenomenon is due to hydrogen going through the paper and so on, causing a chemical reaction, how do you explain it going through an equal amount of thickness of film? These are the kind of things. The interesting thing is when you put a film on one side, it seems to have a back effect on the other side too, although this is in contact. So this is a very recent experiment which was done with a coin-like thing, about 16 millimeter diameter, 1 millimeter thick, electrolytic loading. The exposure for the same maybe 90 hours was so intense, it became so-called solarized, very intense formation. And yet another with various filters, 100 micrograms of glass is completely eliminated, whereas washed X-ray film is still giving an image. So this is a puzzle we haven't understood. We feel rather embarrassed that for the past 3 years we are talking about it without coming up with an explanation of exactly what is causing. Is there some emission really occurring? I'll leave that and go on to the next. This is electronic imaging of tritium distribution. It has been our aim to find a very simple technique of measuring the presence of tritium on any solid sample. If it's a wire, kind of wire that Tom Slater uses, or the kind of wire we use, and this is the imaging technique. We reported on this. The essential physics lies here, the sample is here, and they have there's a scintillator, and the scintillations caused by this are intensified by these imaging infrared tubes, which are essentially produced for the Defense Department, the infrared night viewing thing. 2 of them give a gain of almost close to a million. CCD camera, the frame driver. So you see the image forming on the video monitor, which you can photograph or you can print out on it. You can even record the experiment as a function of time. For example, if you have charged particles, things Dr. Sara was mentioning, we could observe the presence of charged particles as a function of time and see correlation. So it took us a long time. Of course, alpha particles was very easy to image, neutrons were easy to image. To find a scintillator that could image 10 keV, 18 keV tritium, it took us a long time, and finally we found the right composition. With this, we are able to take an autoradiograph in just 5 seconds of exposure, which used to take us several hours. I think here is, for example, some, these are not very good. Some autoradiograph, here is tritium distributed in powerful across, but these were rather high, 1 millicurie. So these were titanium chips. Actually, we reported the production of tritium in titanium, liquid hydrogen cooled titanium in 1991. And those same chips, even after 5 years, are still showing the autoradiograph, and they are also giving beta emission and the titanium K alpha X-rays in the scintillation counter. So that is the technique of imaging, and this is going to be useful for us in what I was telling a little while ago, electrolytic loading of tritium labeled hydrogen. I already talked about this. The T2H ratio here is 1 ppm, and the loaded samples are counted by conventional autoradiography, electronic imaging, just I mentioned, gas counting, and objective study of non-uniform loading, particularly hotspots and so on. And eventually, if we do find hotspots, to try and correlate it with metallography with the metallurgy part. But there again, no exciting results, it's only development of the technique. The next experiment, anomalous heat production in nickel hydrogen systems, which is our attempt to reproduce the BNT experiment. We talked about it last year. But most of you know about the BNT experiment, but the important point is BNT did point out the important role that magnetic field plays in the system, the nickel hydride system. And I want to present to you some interesting observations which came out during one of our experiments. See, when you take a nickel wire and study its voltage current characteristics, doesn't matter whether it's in vacuum or in hydrogen gas, we find that it has 3 regions, and interestingly, this is how the current varies with the voltage, and the ratio of course will give you the resistivity. But if you plot it this way, there is something interesting that emerges, and we again talked about it last year. And there, just above the Curie point, the differential or incremental resistance is absolutely straight. I think the VI characteristics is absolutely a straight line above the Curie point. Now, what we found was in one sample, it was amazing. It showed a fantastic magnetoresistance effect. The same curve, this is the unloaded wire, and this is what we used to get with every nickel wire, whether it's plain virgin nickel or hydrogen loaded. But one particular wire gave us a very interesting effect that the resistivity suddenly, in the presence of a magnet, dropped. In other words, This is how the experiment. The experiment is very simple. This is the coil of nickel. This is loaded in ordinary hydrogen gas. Just keep a bar magnet, maybe about a few hundred gauss, maximum be a little close to 100 gauss the magnetic field perhaps. And in this position, it was just mounted with a clamp and so on. They were able to show that with and without the magnet, the resistance changes, but the effect was there only below the Curie point. And if only, I think he's telling us something that when nickel hydriding is affecting the magnetic property, but unfortunately this was the only one sample gave us this effect. If only we had reproduced it once more, we would have published it very boldly. That's the nickel hydrogen experiment. Let me now go on to tritium production in nickel cadmium batteries. After the repeated charging, discharging these commercial cells 100 times, it would take us a whole day for charging at a rated current and a whole day for discharging. So one cycle of 100 charging loading typically takes several months, maybe 2 or 3 months. So after such charging loading, it is split open and the anolyte and the catholyte is essentially KOH dissolved in HCl, digested in HCl and made up to 100 ml. And then by conventional liquid, after distillation, it is counted, and these are the results. The used cell, the first experiment we started in 1995. We just pulled it out of somebody's cupboard, and this was supposed to be unused, and this was supposed to have been used maybe once, maybe twice, but all of them gave more or less, this is in units of millibecquerels per ml of a digested solution. Anolyte, catholyte. We were hoping that maybe the anolyte may show, the cathode region may show higher amounts, but since there is a stainless steel mesh between the two compartments, I suppose there is no meaning in trying to keep the anolyte and catholyte separate, but at least we can look upon it as two separate measurements. Now, all I can say here is out of the 15 experiments we have conducted, 3 into 5 and 3, 8, 16 analysis. Although every charged star cell does not show an increase in the tritium level, we can say that whenever there is a tritium increase, it has always been the case where cell subjected to such charged star shock. So there is a suggestion that tritium is being produced in any nickel cadmium cell. But of course, in this result is only 50%. Right now, one more cell is being dissolved, it's going on, the result will be ready by the end of the week. So maybe a few more will be in a position to confirm whether there is tritium production in commercial nickel cadmium cells. This is the possible transmutation of elements. We selected the so-called green grams kind of lentil. This is being done by the analytical chemistry division. The plants are grown under very clean conditions by the biotechnology of the nuclear agricultural division of BARC. They are familiar with the whole business, so there are botanists and they have all the equipment. The plants are grown under clean and controlled conditions, double distilled, dust-free water, either under natural or artificial light. The seeds and plants are then powdered and analyzed by two techniques, atomic absorption spectroscopy, neutron activation analysis. And the problem with these two methods, the conventional method of doing the manner that was reported by Kalra and others, is they take samples of 5 grams or 10 grams of seed, completely destroyed in analysis, take another set of 5 or 10 grams, grow that, and then do the analysis. And so the doubt arises, how do you know that the elemental composition in the seeds that were grown were the same as the seeds that were used for testing, because there is a certain statistical distribution. To avoid that, what we are trying to do is take what we call single seed irradiation. Take the same seed, put it in the thermal column of the Apsara swimming pool reactor by neutron activation analysis, get its sodium, potassium, calcium content, and then grow that, and then look for change in elemental composition. That way, at least we know that the initial content is known. But the problem with that is, it is possible that exposure to a low neutron flux might affect its plant growing conditions. But our people who have done such irradiation experiments tell us that a total fluence of about 10 to the 14 in thermal neutrons. If you do it in fast neutrons or high gamma field, yes, it will have an effect. But in thermal neutron field, where this gamma flux is suppressed, it may not. So these are the seeds, these are the grown plants, and these are analyzed, these are like separately. That's kind of experiments that are going on. Again, I will not say, although I have some results here, a large number of copper, zinc, and so on. I think until we have something definite, we shouldn't talk about it. But I think it's of fundamental importance to science to answer the question which was thrown open nearly 30 years ago by Beranga, the living sense group, and I know in Japan there are several groups who have been also doing similar experiments. I think I will stop here. Thank you very much. Just give a flavor of the kind of experiment going on, and all I can say is that cold fusion is not dead in India, but it's going through the same difficult phases, non-reproducibility. I think I have one this thing. We are also attempting to reproduce the Patterson cells. Some coated beads have been made. I can just flash back to say that this is in the chemistry department, metallurgy department. They have nickel and palladium coated 2 micron bed material. So such beads have been made, but we haven't done any excessive measurements, or that group has not done any excessive measurements and so on. Thank you.
Thank you very much. As we know, India is one of the most active countries in the cold fusion researches from the first discovery of this phenomenon. And we had very interesting reports, a recent one from Dr. Srivas. Any comments or questions, please?
In the helium and hydrogen system, how about the X-ray imaging or picture? I think the radiation or emission with X-ray, so the photo show us the X-ray photo. Maybe.
You're talking about the palladium, the so-called palladium luminescence in palladium hydride experiments, right? I didn't understand the question. Most of the pictures I showed were with medical X-ray films, and the exposure was typically about 90 to 100 hours of time. We have never been able to get any signals with such samples using any kind of particle detector. The question we are asking is, are these images formed due to the emission of any low energy X-ray photons, or is it merely a chemical effect? To rule out the possibility of a chemical effect, we have shown that if we take a sample and put 2 X-ray films, one behind the other, both of them show the image. If it was due to the hydrogen penetrating, you cannot explain the image formation in the second film.
I think the photo imaging made with the X-ray.
Right. It's an X-ray film, but X-ray films are sensitive to betas as well as visible light. So we do not know. One of the questions people are saying is, maybe the hydrogen interacts with the oxygen in the atmosphere, gives out visible light photons, which pass through the film. So that's why we did the experiment both with black paper and white paper, black colored film as well as white colored film. So we have no conclusion as to what is causing it, but I feel it is definitely not a simple chemical explanation.
I have just advice. You can measure the scattering electron, the compound electron. You can measure the electron.
We take the palladium hydride sample and do X-ray scattering, X-ray diffraction.
Electron, the compound electron.
Okay, maybe
so
we
the energy ranges from 100 EV.
But maybe I should mention, in recent experiments, we also exposed these palladium hydride samples to TLD detectors, thermoluminescence detectors, and even they have shown a response. So in a thermoluminescence detector, there is no this kind of possibility of a chemical reaction. So I think there is something nuclear or electronic going on, and it's very unique to the palladium hydrogen system. We do not get such wonderful photographs with either nickel hydride or titanium. Never have we seen with titanium. Yes, with nickel we have seen sometimes, but nothing as beautiful as the palladium hydride.
Other questions? Please.
On dealing with nickel, did you try to reproduce Piantelli's results?
We did. Our whole effort was to try and reproduce the Piantelli's results, but we never got any excess heat. But we did see tritium production in a nickel hydrogen system, which we reported last year on a nickel hydrogen. But we never got any excess heat. The particular geometry was very simple because we are heating it electrically. We know the amount of power we are putting in. We had an outer jacket through which water was passed. We measured the delta T. We had a good calorimetric system, but we never observed any excess. But again, as I said, there is the condensed matter aspect of it is very interesting, as you pointed out. The resistivity is telling us something. Nickel hydride is also. The fact that nickel hydride resistivity is there, that the nickel hydride produces tritium. Of course, we have seen the PNGL and other experiments. So, some interesting physics. Thank you.
That's a question.
By the way, you have about 20 different groups.
Not 20. This is 12 experiments, but in many experiments the same groups are doing. So effectively there are about 5 or 6 groups, and maybe altogether 15 people involved at present. And these are all the people are working only part-time because they all be having given other assignments. Some people of course are more 90% of the time, but by and large this is part-time work.
Do you discuss among yourself what
Yes,
experiment
we have.
you should do next?
Yes, we have what is known as a Cold Fusion Forum. We have monthly meetings. We discuss papers published internationally. We have put up proposals to include in our 9th 5-year plan. We are asking for $1 million in the next. It's not very much from your standards, but this $1 million is only for materials, not the salary. So there's a good chance we may get some support. The government has not. The director of our center has never said stop working on cold fusion, but he will never support it like he does some other. So we are given that kind of state. They are allowed to work. They look the other way, and at least this time they funded me to come here. So to that extent, I am happy that they are supporting me.
Other question? I have a question. Bionuclear transmutation was reported several times. You told one example in your laboratory.
We are attempting to prove it or disprove it, one way or the other.
Perhaps there is some special care to treat bio system compared with the physical chemical system. What kind of
I don't know whether you have read the original works of Louis Calvin, those books. In fact, Louis Calvin had a series of 4 books, and I think the first was in English, and others are probably in French. In fact, that book called Low Energy Transmutations in French has been translated in Bach. We are trying to see if we can get it published for the first time in English. And it's very interesting, and he has pointed out it is the enzymes in nature. I think biological systems, if those of us who have been fascinated by the wonderful things that the cell does in the DNA and so on, it's very easy for us to conceive that the same mechanism can bring together nuclei in a system. So I think living systems probably have a clever way of doing things than probably non-living matter. So I think it's very conceivable for me, but we would like to prove it or disprove it. And if it is shown that elemental I can just mention a little quotation. There's a doctor in Bombay who has used, he's a homeopathic doctor, and he got the idea of using the concept of biological transmutation to try and explain some of the fantastic things that happen in homeopathic medical system. And surprisingly, the papers he presented were so well received by the homeopathic and alternative medicine communities. Some people went to the extent of nominating him for the Nobel Prize this year. I saw the letter. I mean, biological transmutation and homeopathy put together. The homeopathic people are fascinated. Maybe he can explain some of the manner in which. So I think there's a lot of interest, of fundamental scientific interest to answer the question one way or another.
Any question? Okay. Again, thank you. Thank you for the two speakers in the evening session and the audience cooperated with us. Thank you very much.
Thank you very much, ladies and gentlemen. This will end all the sessions for today. Tomorrow's morning session will start from 9 o'clock, and the first category will be NHE session 1. And also, I'd like to remind you once again that posters may be set up till 11 p.m. tonight, and from 8:30 to 10 tomorrow morning. Thanks very much.